So good morning, good afternoon, good evening, wherever you are. Thanks for joining our second Q&A of the week. I'd like to introduce myself. I'm Chuck Collins. I am the Vice President of Sales in the US. I'm based in Atlanta. And on the webinar today, we will be listening primarily to Dermot Quinn. Dermot is our Chief Technology Officer, our Chief Operations Officer, and DP Limited over in the UK. He's a founder of digital projection and a pioneer of the world's first 3-chip DLP projector. Dermot, are you there?
Hi, Chuck. Can you hear me?
Yeah, you sound great.
Okay, good. Everything's working then.
Yeah. Also joining us today is Mike Levy. He's the president of digital projection here in the US. He is also a founder of digital projection, and I think you had a little bit to do with the world's first 3-chip projector as well, did you not, Mike?
Well, to be honest, no, I didn't. When I showed up, it was already there, making beautiful pictures. Welcome, everybody. Appreciate you joining the call today.
Thank you, Mike. We also have Kyle Greetham. He's our marketing and communications manager here in the US. Kyle, are you there?
I am indeed. Good morning, everyone, and thank you for joining us and submitting your questions ahead of time. If you have any questions while we're speaking, please feel free to submit those via the questions tab, and we'll get to them as time allows.
Yeah, Kyle will be joining us later, asking some of those great questions that you've already submitted. And as Kyle said, as Dermot is talking with us, I'm sure more questions will come up, and just feel free to let us know and we'll get to all of them. And then finally, I'd like to recognize Dana Forehand. She's also in our marketing department and handling all kinds of technical logistics in the background. Dana, are you there?
Yes, I am. Good morning.
Hey, welcome. Hey, can you tell us who some of the countries that may be joining us today? I know we're not just in the US.
Yes, we have people joining us from Australia, Austria, Canada, Cyprus, Denmark, Estonia, France, Germany, Greece, India, Ireland, Italy, Luxembourg, Netherlands, Poland, Portugal, Russian Federation, Saudi Arabia, Singapore, Slovakia, Spain, Taiwan, United Arab Emirates, United Kingdom, and the United States. Welcome, everybody.
Wow, that's fabulous.
Indeed.
Thank you, everybody. So, Dermot, how do you want to get started with this?
Well, I thought I'd by way of introduction, go through a little bit of a presentation that I put together that talks about principles and reasoning and what we think are the benefits behind our MLS and satellite technology. So shall I kick off on that?
Yeah, go for it. Thanks.
Okay, good. All right, well, what we call our MLS, and by the way, my laptop has, okay. By way of introduction, a little bit of history. As Chuck mentioned, we were involved in the development of the first DLP 3-chip projectors, and that's 23, even 24 years ago now. And there's a picture of our Power DV projector, 3000 lumens, 800 by 600 SVGA resolution, and it used a thing we called a Surmax lamp, which cost me several years of my life. Every edge of it, every element of our product was pushing technology in order to couple energy onto those DMDs, but it was revolutionary. It made pictures that couldn't be made any other way. And since then, we've been in a technology race, especially during those early years. Every year we stepped up the resolution through SVGA, XGA, SXGA, SX Plus, and then ultimately we got to what we thought was the holy grail, which was 1080p resolution, real HD. And other stuff was going on, of course. It was resolution and lumens. And as we moved through various aspects of that, we also went through from different kinds of xenon lamps, different arc lengths. Then we made the move over to very high pressure mercury lamps. And then in the last few years, we moved over to laser phosphor-illumination technology. Now, during those years, that product was revolutionary at first, but then the market's now mature. There's lots of choice amongst projectors, and there's a lot of competition from very good manufacturers. So not only are there other projector manufacturers, but there are other technologies which have encroached upon aspects of business and solutions which were solely originally the area of projection, but now LED walls can light up spaces, big surface areas with very punchy images, and they can compete with ambient light. Flat panel displays have got better and larger and cheaper, and therefore some applications, for example in education, in classrooms and colleges, and in home theatres, LCD and OLED panels are taking up some of those solution spaces. And then of course within our own range, our own lower cost, for example, single chip projectors have become more and more capable. So why do people still need projectors? And the particular question I ask myself is, why would people need high-end 3-chip projectors? Well, one answer is where the shape or size of the image can't really be achieved by an LED wall or flat panel. And in those aspects, and there's a couple of example pictures there, you know, you're projecting on a complex surface, either a building at night, and that's the Tower of David in Israel, or for the other example, in some kind of simulation or visualization application where we've got a toroidal surface, then projection is a really good solution. And in some cases, it's not possible to put other infrastructure associated with, for example, LED walls into those areas. And I'm sorry about the hesitation, my laptop. The one thing you can say about a projector is that a small box can make a very big image with little or no other infrastructure. You just need a screen or a white wall, and you need a little small box and a clear path between the two. So projection has got that advantage, potentially. But is it a small box? Projectors are getting brighter, but as we've introduced more and more powerful laser and laser phosphor-illumination technology, they've become more complex. So the projector gets bigger, it makes more noise, it consumes more power. It makes great images. Laser phosphor has been wonderful in moving us away from some of the inevitable unpredictability associated with all lamp technologies, but it has had those disadvantages in terms of power consumption and size. And you know, once you get to projectors that are 100 kilograms upwards, it's challenging at every stage for installation, supply, shipping. All of the logistics associated with those things are quite difficult. They're quite difficult to service in the field, particularly in a high traffic installation where maybe people want that projector to be working 24/7. And going in there and accessing projectors that may weigh upwards of 100 kilograms, it adds an overhead. Sorry, wrong way. So a challenge we ask ourselves is, can we focus our resources and offer our customers something that's easier to install, gives them a lower cost of ownership, gives them the potential to increase the footfall and revenue generated in their installation? We want to offer people something new that really solves their problems. So over a year ago, we set ourselves a goal and we wrote down the vision that said, during 2020, we undertake to start shipping a family of fully qualified certified products that we believe can help us better accurately target the needs of our customers. And more than ever, I would say, during this coronavirus crisis, we're all asking ourselves, how do we emerge into a different world? And the one thing I can be certain of is that we have to offer people things that really do satisfy their particular needs of their installations, and not ask them to accept anything generic and shoehorn it into their solution. And the word I've highlighted below, modularity, is what enables a simple range of building block products to be combined and create a complex, sophisticated range of solutions, a matrix of solutions in a cost-effective way, and that makes us give differentiated performance to the customer. And so the concept we came up with, and it's not entirely unique, but it is the first time that it's become practically available. We said, let's set ourselves the target of creating modular light source, a fiber optic up to say 100 meters long, linked to a projector head, and let's show people great images. To start to appreciate some of the benefits of that, we looked at the sort of grayed out model there. The ghost model is what might be our Insight projector. And we ask ourselves, right, if the light source wasn't in that projector and all of its associated cooling and power management, then what actually has to be local to the lens in what we call a projector head? And you start to create something that is a fraction of the size and weight of an integrated equivalent projector. So we start to develop the concept of projector heads, and there they are shown against an integrated projector as a couple of examples. You can see they are a fraction of the size, and actually that photograph doesn't do it justice. They are very, very much smaller than the integrated projectors. So we want to create a matrix of solutions from a simple range of building blocks, and that gives us the versatility to accurately match customer needs in a cost-effective way. It's modular, it's easy to ship and install, and that means it's a one-man lift or an easy two-man lift, each element of the system. We can use the same projector head for low or high lumens. It's scalable because you can attach 1, 2, 3, or 4 light sources to that head. So it can become, for example, a 10,000, 20,000, 30, or 40,000 lumen solution. The projector head doesn't change. The way that you combine elements of the matrix of building blocks alters. Those light sources, we call them MLSs, can be remotely located. So all of the power and any of the noise and management associated with light sources can be in a service room well away from the projector head and the audience. And that makes everything simple, reliable, and serviceable. The projector heads themselves consume very low power. That means they can be quiet and they've got low thermal dissipation. That means that if you're putting them outside and you need them in an environmental enclosure, it's a vastly easier task to design and manage. They can be in any orientation, and the word unobtrusive is the one that matters here. Imagine we're in an architecturally sensitive installation. There are people who've talked to us about putting these things in medieval cathedrals in Europe. They don't want to see the projector. They want the smallest possible box in an unobtrusive way. Therefore, if it's quiet, it's small, it doesn't consume much power, it's not there. Another side benefit of this thing, I almost regard it as a side benefit. For some people, it's the core benefit, is in achieving this, we move from laser phosphor technology, which has been wonderful in the way that it's improved the predictability and robustness of our products. But moving over to direct RGB laser gives us amazing color space. Now, a couple of the example here, I've plotted out a comparison between high-def TV, so Rec 709 color space, which is pretty good color. It's what you see on your high-def TV at home and on all good quality projectors. But a lot of people ask, well, how close are you to BT 2020? Well, if you look at the dark blue triangle there, BT 2020 is almost fully encompassed by the color of our RGB MLS and head. So only in a very, very small area up on the upper part of the graph is BT 2020 not fully encompassed. So near as damn it, we exceed BT 2020 color. I've shown it for completeness for anybody who's also interested in U prime, V prime color space. And it's even more graphically shown, actually. So the other thing that happens when we use RGB lasers coupled via fiber optic into our projector heads is that we can enhance the contrast of the system and give a punchier image, but maintaining light efficiency. Additionally, because of those modified optics, we get fantastic luminance and color uniformity across the image, and also every pixel from the center to the corner is in focus. It truly is wonderful in those respects. So what does a system of projector heads and modular light sources look like? I think I already did that slide. The other thing that we can do, just to mention briefly, is as these projector heads get smaller, we can start to think about them in some theatrical type applications where they're on moving mounts. We can then think about putting tracking cameras on them, and we can start to think about them as hugely sophisticated stage lights where we can follow action in an automated way of actors or dancers on a show. They can be used to project the background in a theatrical environment. We could add later infrared cameras and tracking within the system, so that they really could transform the theatrical projection market as well as our traditional markets. So going back and a quick overview of what are the elements of the system. Well, we've got the modular light source, the MLS. We've got what we call the satellite link cable, the fiber optic. And then we've got the satellite heads themselves. Now, that modular light source is common. It's a uniform building block. We have a range of projector heads, satellite heads, we call them. And then we have the laser light pipe options that we will build a range of. We'll offer a standard range of lengths and combiners of fiber optic. We decided to keep the projector heads relatively simple in functionality and in inputs, but they focus on absolute optimum image quality. Nothing in their image processing degrades the quality in terms of video processing. So they are the world's best images, quite frankly, both in terms of the bit depth of their processing, the frame rates of their capability, and in terms of their optics. So we're beginning to develop a family to create those range of solutions. You can see here our Insight head, our Titan head, our highlight head, a single modular light source, and then an actual photograph of a rack of 4 modular light sources that we put together and combined. So as I said, we have an MLS, a cable, a satellite link, the projector heads, and we have a control module. And I'll talk a little bit more about that in a moment. The modular light source, each building block is 10,000 lumens at a D6500 white point. That white point can be varied, the thing can be tuned. What's unique about this is that the light source, if the customer wants a different, wants 5500 or 8000 Kelvin, we can modify the balance of RGB within the light source, so it's fundamentally providing that. It's important to say that that 10,000 lumens has to be stated on the assumption that it's going through a particular length of fiber and a particular type of projector head. However, just for reference, we're saying, okay, it's a 10,000 lumen module when measured at D6500 through a 10-meter fiber and one of our projector heads. That's what you'll measure on screen. There are multiple configurations. We can say 1 light source to 1 projector head. We call that a 1-to-1 system. We could have multiple light sources to 1 projector head to make a very bright image through 1 projector head. But something that a number of people have expressed interest in is saying, well, I don't need huge amounts of lumens, but it is very valuable to me to have 1 shared light source amongst several projector heads. So we call that a 1-to-N solution. We insisted in our specification that the modular light sources are self-contained. That means there's no external chiller. This is a genuinely compact, neat solution. And that means that light source can be lifted by 1 person in a staging event or something to consider during an installation. We keep every module within this system compact and lightweight. You can, however, put multiple MLSs in a 19-inch rack. We insisted that full functionality is available over 110 volt or 230 volt for full operation in the US or in Europe without the need for any special power supplies. And we've stated a 30,000 hour life. The fiber optic, the satellite link cable is specialized glass fiber system. We built into it an integrated interlock system, so it's efficient, it's safe. It's a flexible way to deliver light to our satellite heads. It's robust, it's highly protected. We make sure that the bend radius is respected through design. It's crush proof, you can run over it with a forklift truck. It's easy to connect and lock in place and no light can escape. It's very, very important that we make sure that under no circumstances anyone can ever unplug this thing and have laser light escape from the thing, and our interlock system would intervene to ensure that that can never happen. We also, because the fiber optic itself, although it's quite efficient, its transmission is not exactly the same in red, green, and blue, and therefore, through varying lengths of cable, the color balance would shift slightly, and we can compensate for that. We have a light sensor in our projector head which feeds back into the source and can correct. It corrects both for variation in color, and it will also correct for any changes over time by continually monitoring the balance between red, green, and blue. The satellite heads, well, as I mentioned earlier, there are 3 types. There's the highlight head, the Titan head, and the Insight head. And those names are derived from existing families of products, really to follow the lens families. All right. All of those, there are certain aspects that we decided should be common to all of those heads, regardless of what chip size they use and what lens family they use. They're all fully functional at 110 or 230 volts. And when I say 110 or 230, I would add the tolerances to cover operation all over the world. They have fixing points all over them to cover all mounting solutions. They have a common control approach. They have a touch panel on them. They have Ethernet control. We serve a web page from them, and they can tie in with our projector controller software. So you can create a system control. As standard, the heads are sealed against dust intrusion. There is no exchange of air between the outside world and the inside of each head. It may look as though there is, but we draw air in to go straight through a heat exchanger and straight back out. That air does not go into any of our optics. And the design can be extended so that there is some synergy between the way our thermal management works and an external enclosure, for example, an IP65. IP65 simply means that an enclosure could be stood out in the rain. Okay, our standard projector heads aren't designed to be put outside, but they can be easily integrated with external enclosures. They're designed to be 40 dBAs at max lumens. However, our software monitors the actual energy being dissipated in the projector and monitors critical temperatures within it, and it will lower the speed of the onboard pumps and cooling fans to ensure that the projector can be as quiet as possible, bearing in mind its environment and luminance. So it is possible that at lower lumens, the projectors could fall as low as 30 dBA, which is extremely quiet. We've minimized the parts count in all of the heads, so they have a very high mean time between failure and a very long service life. And they'll operate in any orientation. A little more detail about the three types of head. The highlight is based upon our 0.66 3 chips. First of all, it'll be wide UXGA, and a UHD variant will follow. It can handle up to 20,000 lumens, and it can seem a little strange to talk about the luminance level of a projector head that doesn't itself include a light source. However, of course, what we're really saying is you can couple two light sources to a highlight, and that's really determined by the size of the DMDs and how much thermal capability they've got. So highlights okay up to 20,000 lumens. We've got HDMI 2 inputs. I'm sorry, we have added HD base T to it, and it'll be less than 15 kilograms. The Titan head is based upon the 0.96 3-chip DMDs. So larger DMDs, higher thermal capability, wide UXGA with UHD to follow, and that's capable of up to 40,000 lumens. Again, HDMI and HD base T. Sorry, this is an earlier slide, so there's a question mark now that shouldn't be there. And they'll be less than 35 kilograms. The Insight, the pinnacle of our range, is a 1.38-inch 3-chip native 4K DMD. We are already doing 120 frames per second versions, a 240 frame per second version with an 8K capability, and a 360 frame per second multi-view variant. These will handle 40,000 lumens by combining 4 MLSs in a 4-to-1 system, and later those large DMDs themselves will facilitate up to 60,000 lumens. Inputs, 2 HDMI 2s and 2 DisplayPort 1.2s, and that weighs less than 40 kilograms. So that one's not a one-man lift, but it is an easy 2-man lift. And bear in mind that an equivalent 40,000 lumen projector is upwards of 130 kilograms. We talked about these configurations 1-to-1, i.e. 1 MLS to 1 satellite head, multiple MLS sources to a single head, a single source to multiple heads, and even more complex installations than that. And really, the only reason I refresh our minds about those things is in order to talk about control and safety interlocks, we've had to consider all of those configurations. So we come up with a control system where we decided to have a very simple, actually low-cost satellite control module, which acts as a single point external interface. It handles all of the assignment of IP addresses on its own little local area network. So you don't have to worry about it. You as the customer could simply connect to the WAN port on our satellite control module and see the whole thing as one entity. Now, that doesn't mean to say you don't have access to adjust the individual items if you wish, but what our satellite control module architecture does is it allows you to look at the whole thing as a single point of contact and control. It was important to us also, I should add, that somebody can walk into a room where there is a satellite head and treat it as though it is an integrated projector. So he can pick up a remote control and control the satellite head, and he doesn't have to worry about controlling separately the light sources in a separate room. So it can act and be treated as an integrated system. So I've talked about what we were going to do and what our vision was and what our goals were. What have we done? Well, we've done it. We created and demonstrated an Insight head with 4 modular laser sources, and we demonstrated that at ISE running 40,000 lumen stunning images via a 4:1 fiber optic running 20 meters through to the projector head. We've since followed on just before the lockdown with a little bit of a road show where we took Insight and Highlight heads into France and projected images in a number of different venues. So the real message behind these photographs is simply that we have indeed created this solution. It's not just a long-term objective. We have solved all of the key technology issues, and we're in the process of productization to get this thing to market as a family of products to create that matrix of solutions that I talked about earlier. Okay, thank you. I hope that's a useful foundation for some questions.